Okay, so number 9 says a 196.2 kilogram Newton, box. So I'm giving you the weight. It's not in kilograms, so it has to be the FG. It's not the mass. Okay, 196.2 Newton box is being pulled across the floor with a force of 88 newtons, acting upward at an angle. This angle in here, 36.87 degrees. We have Fn, we have the coefficient of friction is 0.244, equals 0.244. And it wants to know what is the acceleration, and then it also wants to know how far does it travel, but we'll get to that in part B. So first find your components. So it'll be cos theta is equal to fx over f, because fx is the adjacent side. So fx equals f cos theta. You could stop here. I probably would, but if you want to find your numbers, you can. 88 newtons times the cos of 36.87, and when you do this, you get an fx of 70.4 newtons. Okay? Then go to the y, and it will be the opposite side, so it's sine theta is equal to fy over f. So Fy is equal to F sine theta. Again, I'd probably stop here, but you can find the numbers. So 88 newtons sine of 36.87, and you get an Fy of 52.8 newtons. Okay? So once you have those, either as letters or numbers, then you go to sum of the forces in the y direction. And in the y direction, it isn't moving, so this will be 0. Fn is going up, Fg is going down, and Fy is going up. So Fg will be negative, Fy will be positive. Always solving for Fn, so take the other two terms over. It'll be Fg minus F sine theta. Okay? You could stop here. I leave it as Fg because they gave us Fg instead of writing it as Fn. But if you wanted to find a value, you could fill your numbers in. 196.2 minus that 52.8 newtons. And you get an Fn of 143, if I could only see, 0.4 newtons. Okay, and then if you want it with this, you could also get friction, because we know friction is equal to mu Fn. So you could write it as mu brackets Fg minus F sine theta, and you could stop here. But since we already have our numbers, you could also do 0.244 times 143.4 newtons. And you would get friction to equal, when you do this, 34.9896 newtons. Okay? And now we go to the x direction. So sum of the forces in the x direction equals max. And so we have our fx pulling forward and our friction pulling backward equal to max. And we're trying to solve for a, so divide both sides by m. So ax is equal to, now if I hadn't found my numbers, I would write this as f cos theta minus, and our friction down here was mu brackets Fg minus F sine theta, and then divide it by m. And now our m we can get from Fg equals mg. So m is equal to Fg over g, so m is equal to 196.2 newtons over 9.81 meters per second squared. So our mass is 20 kilograms. So now I can fill in my numbers. We found above 70.4 newtons minus 34.9896 newtons divided by 20 kilograms. And when you do this, you should get 1.771 meters per second squared. That's part A. Part B wants to know how far did it travel? If the box started from rest, so VI is 0, how far did it go in 6 seconds? Delta T is 6 seconds, and we just found our A. So delta D is equal to VI delta T, 1/2 A delta T squared. this will be 0. Delta D is equal to 1/2 1.771 meters per second squared times 6 seconds squared. And when you do this, you should get a delta D of 3.187 meters. All right, so that's number 9. Number 10 says a 30 kilogram box. It's being pushed. So this is my F. It's being pushed with a force of 200 newtons. This will be my Fx, my Fy, downward at an angle of 30 degrees in here. This is my Fg, my Fn, my friction coming backward. And it says the acceleration is 1.8 meters per second squared, AX. And it wants to know what's mu. Okay? And so we would start again with our components. X is the adjacent side. So you might be able by now to write Fx is equal to F cos theta. If not, then write cos theta is equal to Fx over F and rearrange. You could find your numbers here. So 200 newtons cos of 30. And if you do this, you get an Fx of 173.2 newtons. Y direction should be sine theta, so F sine theta, or 100 newtons sine, doing it in my head, 100 newtons sine of 200 newtons sine of 30, which gives you 100 newtons. Okay, then you go to sum of the forces in the Y. Is equal to MAY goes to 0. So Fn minus Fg minus Fy, because they are both going down. So Fn will equal mg plus F sine theta. And you could either stop here or find the value. So if you find the value, 30 kilograms, 9.81 meters per second squared, plus the 100 newtons we just found. And so it should be 394.3 newtons. Can't find friction though because we're not given mu, so you have to go to sum of the forces in the X. And there's Fx minus friction is equal to MAX. And you're looking for friction. You don't know it, so bring this over. So this will be F cos theta minus MAX. And friction is really mu Fn. And you're really solving for mu, so divide both sides by Fn. And now fill in your numbers. So mu will equal, F cos theta is really 173.2 newtons minus 30 kilograms times 1.8 meters per second squared divided by the 394.3 newtons that we just found. And you should get a mu of 0.3023. All right. Number 11. We don't have time to finish it, but we can at least set it up. Now, number 11 is one of those that is going to cause you a little angst. It's a box being pulled across a floor at a force of 300 newtons, upward at an angle. So my F is 300 newtons. So this will be my Fx. And this will be my Fy, upward at an angle of 53.13 degrees. We have our Fg going down, our Fn going up, our friction going backward, and it tells us that the coefficient is 0.4 and that the acceleration is 1.5 meters per second squared. Okay, and this time they want us to find the mass. So you can start again with your components, and x is the adjacent side, so it's going to be cosine. So Fx will be equal to F cos theta, but this time you cannot find a number because you don't. Oh yeah, you can, but don't, because you're going to be having to fill numbers in. Have to carry your letters, so don't fill your numbers in. And so Fy then will be F sine theta. And now don't fill your numbers in.